Okay, so today we're looking at Unit 8, Lesson 12, with our aim being able to compare the relative sizes of two numbers. Our think about it asks, is the expression 2 times 10 to the power of 2 multiplied by 3 times 10 to the power of 4 equivalent to 2 times 3 multiplied by 10 to the power of 2 times 10 to the power of 4? Explain why or why not, and how this could be used to evaluate expressions with scientific notation. Okay, so if I don't really want to multiply these numbers out in standard form, what can I do to rearrange my multiplication to make this easier and see if my expressions are equivalent? If I want to rearrange my multiplication, I can use the commutative property. Remember that the commutative property means that multiplication can be rearranged in order, but we keep the same value. So what would I want to do with my expression to rearrange the order of multiplication? If I have 2, what value in my expression is going to be easiest to multiply by 2? My other multiplier of 3. So I can rearrange my multiplication and say 2 times 3, and then I can multiply my powers of 10 together after, so times 10 to the power of 2 times 10 to the power of 4. I've used the commutative property to rearrange my multiplication. I can see that on both sides of my equations, I have the same numbers and the same orders of multiplication. But on the right, I have grouping, and on the left, I don't. Are these groupings going to change the value of my multiplication? Remember that multiplication also has the associative property. The associative property says that multiplication can be grouped together differently and still keep the same value. So if I'm looking at my expressions, on the left, I can group together the multipliers and the powers of 10. So I can have 2 times 3 multiplied by 10 to the power of 2 times 10 to the power of 4. Now that I can see that each expression is the same, which means that these values are equivalent to each other. Let's remember that we started by multiplying two numbers in scientific notation together. We use the commutative property and the associative property to rearrange our multiplication to make it easier and see that our expressions are equivalent. So, what key point can I make that tells us how we can quickly multiply numbers in scientific notation? Our key point is going to be that we can effectively multiply numbers in scientific notation by using the commutative and associative properties. Interaction with new material example 1 says, evaluate the expression and write your answer in scientific notation. So we're multiplying 3.45 times 10 to the 4th power by 5 times 10 to the 5th power. Remember that our key point says we can efficiently multiply numbers in scientific notation by using the commutative and associative properties. So our first step is going to be to use the commutative property to arrange our multipliers and powers of 10 together. So let's look. For my multipliers, I have 3.45 and 5. So I'm going to multiply those together first. And then I have my powers of 10 that I can write after my multipliers. So now that I've rearranged the order of my multiplication, my next step is going to be to use the associative property to group similar values together. So when I'm looking, I can group my multipliers and my powers of 10 together using my parentheses. Now that I've grouped my values together, my next step is just going to be to simplify my multiplication. So when I multiply 3.45 times 5, I get 17.25 multiplied by my powers of 10. Again, we can use our exponent rules, so I'm going to have the base 10 to the power of 4 plus 5. I can easily simplify that down so that I have 10 to the power of 9. Our question asks us to write our answer in scientific notation. Is our number and our value in proper scientific notation? No, because our multiplier is not between 1 and 10. My final step is going to be to write the value in proper scientific notation. When I'm looking at my multiplier, what do I need to do to have my multiplier between 1 and 10? I need to move my decimal place over one more spot so that I have 1.725. If I'm moving my decimal place one spot over, that means I need to multiply by an additional power of 10. So if I have 1.725 times 10 times 10 to the power of 9. These powers of 10 can simplify down further. So I have 1.725 times 10 to the power of 1 plus 9, or 10 to the power of 10. Example 2 says a pool holds 8.1 times 10 to the 9 liters of water. The pool is being filled by a hose at a rate of 3 times 10 to the 7 liters per hour. How many hours will it take to fill the pool? So first let's annotate and recognize that we have 8.1 times 10 to the 9th, and that's the total amount of water that our pool holds. We also have a rate or a speed of 3 times 10 to the 7th power. The question is asking how many hours it will take to fill the pool. So how can I write an equation that represents the total, the speed, and the hours that we have? Write an equation, I can have the total amount of water that the pool holds equal to the speed that we fill our pool at times the hours it takes to fill the pool. My total, 8.1 times 10 to the 9th, is going to be equal to my speed, which is 3 times 10 to the 7th power, times the hours it takes, which we don't know. We can represent hours using the variable h. What do I need to do in order to isolate h? Well, in order to isolate h, I can divide both sides by 3 times 10 to the 7th power. That means that we'll cancel out over here, and I'll be left with 8.1 times 10 to the 9th divided by 3 times 10 to the 7th. When I'm looking at my steps, I know my first step says to use the commutative property to arrange my multipliers and my powers of 10 together. I can see with my division that they're already kind of lined up one on top of the other, so I can count that step as done. Let's look at our second step, which is to use the associative property to group my values together. I need to group my multipliers and my powers of 10 together. So I can rewrite that as separate multiplication of 8.1 over 3 times 10 to the 9th over 10 to the 7th. Again, associative property is grouping them together, so I group them as two separate fractions that are being multiplied together. Is to simplify my multiplication, or in this case I have division. So I need to divide 8.1 by 3, which gets me to 2.7 times my powers of 10. It means I'm going to be subtracting my exponents together. Left with 2.7 times 10 to the power of 9 minus 7. I can see that my multiplier is already between 1 and 10, so that my answer is just going to be 2.7 times 10 to the second power. Now that I have my final answer, I can go ahead and write my complete sentence. So it will take 2.7 times 10 to the second power hours to fill the pool. Go ahead and take these steps to complete your independent practice and your exit ticket on Google Classroom.